A study to determine correlation between automobile brand affinity and gender. We are trying to prove a correlation between gender and the make of automobile driven by an individual. Simultaneously, we can use our raw data to observe which brand of automobile is driven most overall. We define the null hypothesis and set our threshold p-value at 0.05. In order to study our hypothesis, we designed a survey study of 2 questions, which was distributed among a randomly selected population via in-person, phone, email, and SMS. Population studied was 30 people, 15 males and 15 females of various ages above the driving age. Participation was 100%, and underage drivers were excluded from the survey. Our survey consisted of 2 multiple-choice questions, one regarding the brand of car driven and the other requesting the gender of the individual. Refer to Table 1 for our raw data collection. An equal number of males and females were surveyed, and the subsequent results are reflected in bar graph form on Chart 1. The data reflects that the Ford make is more popular amongst the males surveyed and Chevy is more popular amongst the females surveyed. A total of 7 males drove Ford models versus 7 females who drove Chevy models. Chevy was the least popular amongst the males and Dodge the least popular amongst the females. Table 2 shows, overall, Ford was the most popular make with 11 drivers, and Dodge was the least popular with 3 drivers regardless of gender. Chart 2 presents the data in pie charts and percentages. 46.7% of males surveyed drive Fords and 46.7% of females surveyed drive Chevys. 6.7% of males drive Chevys and 6.7% of females drive Dodge. 33.3% of males drive other makes and 20% of females drive other makes. The mean of our data was the same for male-female because there were 15 male and 15 female, each divided by the 4 options of brands, so the mean for both groups was 3.75. The median of our data was also the same for the aforementioned reason. There was no mode among individual male-female data as there was no repeating number in the individual groups. However, the total data did yield a mode of 8 for Chevy and other. What the chi-square does is compare the actual or observed data we have from the respondents with an expected value. To begin our chi-square analysis, our observed results from the survey are charted. If there were no relationship between the questions, then we would expect a table that allocates the totals to look like this. This chart reflects the expected results. The formula for the left upper cell is total number of Ford times the total number of females divided by the total table, or 11 times 15 divided by 30, equaling 5.5, and so on and so forth for the remaining cells. Once we have all the expected values, we need to find the difference squared so they're all positive between the individual cells' expected and observed values. Adding all the differences, we get a total chi-square of 6.14. Many statistics rely on a concept called degrees of freedom. The details vary stat to stat, but it's based on the number of variables involved in a calculation. For chi-square, the degrees of freedom are determined by the formula supplied above. For chi-square, the tables are based on the level of risk, with common thresholds of 10%, 5%, 2.5%, 1%, and 0.1%. Each one of those risk levels has a critical value associated with it. In this case, the total chi-square value does not exceed the critical value associated with 10%, so our result is less than 90% significant. Using the chi-square and degrees of freedom value, we can determine a p-value of 0.1050. We had set our p-value threshold at p equals 0.05. Because our calculated p-value is greater than 0.05, we accept the null hypothesis, and our difference is not statistically significant. Any difference observed in the study was probably a coincidence.
The purpose of calculating the mean of a set of data is simply to find the average. To do this, we add up all the values in a set of data and divide by the number of items in the set. For the males in our survey, we added the 7 who drove Fords, the 2 who drove Dodges, the 1 who drove a Chevy, and the 5 who drove another brand and divided it by our 4 categories, giving us a mean of 3.75. Similarly, for the females, we added the 4 who drove Fords, the 1 who drove a Dodge, the 7 who drove Chevys, and the 3 who drove another brand, divided again by our 4 categories for a mean of 3.75. The median involves arranging all the data in order from smallest to largest. Once the data has been arranged, You find the middle number to calculate the median. However, in our case, we had two middle numbers, so we had to take the mean of those two numbers. For the males, 2 and 5 were the middle numbers, so we added them for a sum of 7, then divided by 2 for a median of 3.5. For the females, 3 and 4 were the middle numbers, so we added them for a sum of 7, divided by 2, and also got a median of 3.5. To find the mode of a set of data, we look for the most frequent value or any value that occurs more than one time. Unfortunately, neither the males or females had a category with the same number of participants, so the mode was not applicable for either part. In finding the range in a set of data, we just take the largest value minus the smallest value. For the males, the largest number was the 7 who drove Fords, and the smallest was the 1 who drove a Chevy, giving us a range of 6. Likewise, for the females, the largest number was the 7 who drove Chevys, and the smallest was the 1 who drove a Dodge, also giving us a range of 6. When finding the lower quartile, the value is taken to be 3/4 of the distance between the first half of the ordered measurements. To calculate this, we take 1 plus 75% of the difference of the first half of the data. So for the males, the lower quartile is 1 plus 0.75 times 2 minus 1, giving us a value of 1.75. For the females, we take 1 plus 0.75 times 3 minus 1 for a value of 2.5. For the upper quartile, we are taking the value 1/4 of the distance between the second half of the data. To calculate, we take 1 plus 25% of the distance of the second half of the data. For the males, we take 1 plus 0.25 times 7 minus 5 for a value of 5.5, and for the females, we take 1 plus 0.25 times 7 minus 4 for a value of 4.75. Standard deviation is defined as the set of measurements equal to the positive square root of the variance. To calculate this, we can break the process down into 4 easy steps, which are shown on the current slide. Step 1 is taking the sum of the squares of the individual measurements. Step 2 is taking the square of the sum of the individual measurements divided by the number of measurements. Step 3 is subtracting the answer from Step 2 from the answer in Step 1 and dividing the results by the number of measurements minus 1. Step 4 is taking the square root of the answer from Step 3. The empirical rule is used to detect the gross errors in a calculation of the standard deviation. The rule states that 68% of the data measurements lie within one standard deviation of the mean. This means we can simply take the mean, then subtract and add the standard deviation to get our interval, as shown on the current slide. The empirical rule also states that 95% of data measurements will lie within 2 standard deviations of the mean. This means we take the mean, then subtract and add 2 standard deviations to get our interval, also shown on the current slide. Finally, the empirical rule also states that 99% of the data measurements lie within 3 standard deviations of the mean. This means we take the mean, then subtract and add the standard deviation times 3 to get our interval, like it is shown on the current slide.
The difference of means test. We interviewed 30 random people, female and male, and asked them whether they drive a Ford, Dodge, or Chevy. We're trying to test what brand of automobiles do they tend to drive. After a couple of weeks after interviewing them, the mean of brand of automobiles driven was 7.5. For females, 3.75, and for males, 3.75. The results from the female were as follow. 4 females drove Fords, 1 female drove Dodge, 7 females drove Chevy, and 3 females drove a different type of brand. For the males drove 7 Fords, 2 Dodge, 1 Chevy, and 5 other different type of brand of automobiles. So, what's difference of means test? I'll explain the process of estimation, especially the estimation of mean differences, provides a relatively simple and direct method for evaluating effect size. The mean of brand automobiles driven was 7.5, as stated above on the slide. Female and male came up with the same mean, so that states that female and male are evenly divided between brands. We calculate two means and compare them to see if one is greater than the other and by how much. The first step taken is to compute the statistics, which is simply the difference between means. So we take the mean difference of the female data and the male data, which for female the mean is 3.75, and for male the mean data is 3.75. So what we do is take 3.75 minus 3.75, which equals to 0, recognizing that a mean difference of 0 is exactly what would be predicted by the null hypothesis. So that says that there is no difference. It's basically evenly division between the brands.
Survey summary. We did a survey on what percentage of people drive a Chevy, Ford, Dodge, or other make vehicles to find out what people prefer to drive. We also wanted to compare the percentage of males and females who preferred the aforementioned companies. We interviewed 30 people through in-person surveying, phone calls, text messaging, and emails. The results: 37% of people, 47% of males, and 27% of females prefer to drive a Ford. Ford was the only American Big Three car manufacturer not to take the federal bailout money. That turned out to be a great decision because sales and consumer confidence have increased for Ford in the last couple of years. 10% of people, 13% of males, and 7% of females prefer to drive a Dodge. Dodge, which is owned by Chrysler, was the least popular car company in our survey. (26.5% of people, 7% of males, and 46% of females prefer to drive a Chevy. Chevy sold 2.35 million cars globally in the first 6 months of 2011, the best half-year performance in Chevy's 100-year history. For the first half of 2011, Chevy recorded sales in all of its top markets, including the United States, Brazil, China, Russia, and Canada. (26.5% of people, 33% of males, and 20% of females prefer to drive a vehicle that is not a Ford, Chevy, or Dodge. People who do not prefer American-made cars say that American cars are of low quality and don't last long, shrinking the resale or residual value. Conclusion. From doing the survey, we concluded that Ford was the most popular amongst people and Dodge the least popular. Ford was the most popular among males and Chevy the least popular. Chevy was the most popular among females and Dodge the least popular.